Now I'm going to explain direct online starter, right? So if you clearly observe the diagrammatical representation of it, it is a three-phase supply, right? And this is the main switch we have, and these are the thermal relays which are used for overload protection, and this is a contactor, and this one is the magnetic coil. NO switch that is normally open, and NC switch that is normally closed, right? I'll be explaining the operation of it, don't worry. And then we have the stator, and this is the squirrel cage rotor we are having, right? So what is the, see why it is directly online, right? So the motor is going to be directly switched on from the three-phase supply, right? How it is going to be working. See, when this NO is going to be pressed, that is normally open is going to be pressed, what is going to happen, this magnetic coil will be energized so that it will attract this contactor. So that what is going to happen, it is in on position, the motor will be in on position, and when we are going to press this NC, then the magnetic coil will be de-energized, so that the motor will be in off position, right? So this is what the working of this DOL starter. And moreover, if you are having any kind of overloaded conditions, then over excessive heat will be produced in the motor, so that in order to avoid those excessive heat, then thermal relays will be used, right? So this is the working procedure of DOL starter, right? Now let us discuss on the torque equations. See, we know the rotor power input is given as 2 pi ns into t by 60. That is simply we can consider this torque is directly proportional to what? P2, that is rotor power input. P2 is nothing but PC by S. You see, refer to the previous lectures, you will be come across this kind of equation, that is rotor copper losses by S. So simply, if I am going to take R2 as constant, torque is directly proportional to what? I2 square by S, right? So before we have studied that I2 is directly proportional to the stator current, right? So torque is directly proportional to I1 square. So this is if proportional to constant is going to be denoted by k into I1 square by S. So at standstill conditions at S equal to 1, I1 is equal to I starting. So T starting is equal to what? K into I starting square, right? So let it be equation 1. So at full load, TFL is K into IFL square by SF, that is full load slip. So equation 1 by 2, if I go for taking equation 1 by 2, so I'm going to get this equation as TST by TFL equal to IST by FL into SF. So it is, I think it is square, sorry. So finally, the starting torque is given as TFL into IST by IFL whole square into SF, right? Thank you.